As we all know, an antenna is an electrical device that converts radio frequency fields into alternating currents and vice versa. Recently, for the fifth generation wireless communication requires antenna which supports a wide bandwidth because higher data rate can be transmitted. So here from millimeter wave bands, the 28 gigahertz particular interest defined from Ka band as frequency range 26.5 to 40 gigahertz are now low cost antennas which are being put into pictures for the research and development purpose. The 28 gigahertz band is currently available over the 1 gigahertz spectrum bandwidth, and also directions have become moving to empower outdoor operations. So based on this reason, low profile antenna are required when the cost, size and weight of installation can be put into picture. So here we have designed an antenna with the ZH and the E plane, which is the 3D view you are currently seeing right now. Now the green color strip you see is a microstrip patch. The orange color orange color thing you see is the substrate, the dielectric substrate. Now you might ask, what are the specifications for the material selection once we put this into fabrication? So for picking a substrate, you will need to keep two things in mind, which are the thickness, dielectric constant, and also the stiffness, which is directly proportional to the loss tangent. The dielectric constant should be as low of convertible energy because of the radiation pattern. A thicker substrate should also be considered because of the increase in impedance bandwidth. Moreover, using a thick substrate would enhance the accuracy, since most of the microstrip antenna models use a thick substrate approximation in the analysis. As you can see, you can select the ground as well as the patch required in the perfect E-plane. The representation here you see is the radiation pattern and also how it will be seen on the material itself. So this is the RE plot, and this is the simulated wave of VSWR, which is 2.13 dB at 10.15 gigahertz. Measured value at resonance is about 10.11 gigahertz to 1.24 dB, which is nearly to perfect matching condition, which we had considered as 1 dB. Now here the proposed antenna design has the following parameters. The ground plane length and the ground plane width is around 20 mm. Patch length is around 10.2. Patch width is around 7. Field line length is around 7.2 mm. And field line width is around 1.9 mm. Substrate thickness is around 1.6 mm. Patch slot length is around 9 mm. And patch slot width is around 0.8 mm. Now here whatever specification you are selecting will be highlighted, which is the main advantage of this software over any other softwares. This simulation can also be done in MATLAB, but these specifications cannot be taken into consideration. So this is a better enhanced 3D view you are able to see. So the patch antenna resonates at 10.5 gigahertz with a return loss about minus 18.27 And the covering band is around 9.95 gigahertz to 10.35 gigahertz after simulation. After testing the design, the resonant frequency achieved is around 10.11 gigahertz with a return loss of minus 19.30 dp. Total bandwidth coverage is around 380 megahertz. The radiation pattern you see is a omnidirectional radiation